everyone. My name is Ramata Kintola, and I'm excited to introduce Swarooprani Manoor. She will be given a talk titled Can We Add Objects the Way We Do for Numbers? Swarooprani Manoor is an assistant professor in the Master of Computer Applications Department at KLS Gokte Institute of Technology, Belgavi, India. She has over 20 years of teaching experience. She's passionate about making technical education accessible. She has contributed and conducted several Python workshops for colleges and schools, including a PyDiverse workshop at PyCon India 2023. She's been a regular speaker at community events and conferences such as PyLadies 2023, PyLadies 2024, and Pi 2024. She's a well known technical communicator and she runs a popular LinkedIn newsletter, Python Unlock Your Skills, with over 1,150 subscribers. Join me as I welcome Swarooprani Manoor.
Hi everyone, it's really nice to be here at PyLadies and thank you so much for joining me today. Let me start with something very simple. Let us consider the plus operator in Python. We have all used this plus operator in Python and maybe for adding numbers or concatenating or joining the strings or maybe to combine the lists and various other purposes. But here is an interesting thing. Whether this plus operator works on objects created by user-defined classes, whether it behaves same on the objects. Let's say we create complex class having real and imaginary parts of the data members, or maybe we create a class time with minutes and hours as the data members, and we create some time objects. And if we wish to add these time objects using the plus operator, whether it behaves the same as it behaves with the built-in types. Just like adding 2 and 3 we get 5, whether we get that with the objects created by user-defined classes. It works, but it cannot do it directly. You have to do something additionally. You have to have special methods to do that. This is because Python doesn't know how to behave or how to make the operators behave with the operands which are not built-in types. Built-in types, the numbers, floats, strings, lists and various other things we have, right? So whenever the plus operator sees these operands which are built-in types, it knows how to behave with them because the rules are defined. It knows how to treat them and what to do. But whenever it sees the operands which are not built-in types, it has no clue what to do. So it will throw some error, like it doesn't understand what is to be done. So you get an error message there. So how to deal with such scenarios? Or is it not possible to add objects at all? It is possible to add user-defined class objects, but we have to do some extra thing there. So that is what is the agenda for this session. We will see how we can add the objects the way we do it for built-in types. So by the end of this session, you will know how to teach the plus operator to behave with the objects created by the user-defined classes. So let's get started. Let's look at something very familiar first. Here, when we write something like 2 plus 3, Python knows that both are integers, and so it simply adds them and gives us 5. If we try 1.5 and 2.5, both are floats here, Python adds them up and gives 4.0. Even if we mix them, like 4 plus 2.5, here one is integer and other one is a float, but Python handles it gracefully and it knows how to convert, and it gives us the result as 6.5. And of course, with strings like hello and world, it will just join them and gives the result as hello world. All of this works so smoothly because Python built-in types already know what plus means for them. So they come with predefined rules for how the operator should behave. But what if we try the same plus with our own classes, say time object? Python will have no idea what that means and it will throw a type error. So let's see that next. So here I have created a class time. Inside it there is a method init, that's the constructor in Python, and it runs automatically when we create an object, and it is used here just to set the initial hours and minutes. So I have created two objects here, T1 and T2. T1 represents 2 hours 30 minutes and T2 represents 1 hour 45 minutes. Now let's try adding them the way we did it for numbers 2 plus 3. Same way here we try to add T1 and T2. So I have just written it as T3 equals to T1 plus T2, and it feels like it should work, right? We are just adding two time values here, so it should be fine. But Python doesn't think so. It throws a type error. It says unsupported operand types for plus. That means plus operator doesn't know what are the operands here. They are unsupported. And that's because unlike integers or strings, Python has no built-in rules for what the plus should do for the time class. So we haven't told it yet, right? So right now Python is basically saying, hey, I don't know how to add these two things that you have created. So does that mean we can't add or subtract objects at all? We can do that. So let's see how we can do that. So here it is possible to add our own objects too. We just have to write our own method for this. Here I have slightly updated our time class, and we still have the constructor, that is to store hours and minutes, and but here you can see that I have added a new method called add. So this method takes another time object, adds the hours and minutes, and returns a new time object with the result. So when we call t1.add, it works fine, no errors this time. You will get the result correctly, that is 3 hours 75 minutes. It works, but it doesn't feel very natural, right? So here what I did, I used the add method. I have to call it if I have to add it. Whether we did it for adding numbers or whether we did it for strings or any other types, built-in types, we didn't do that, right? So if I had to add 2 and 3, I just wrote it as 2 plus 3. I did not write it as 2 dot add and pass 3 as another parameter to that. We didn't do that. So that doesn't look natural. But here I have to do this because plus doesn't know how to, you cannot add just the way we did it for built-in types. But it doesn't look very natural. Wouldn't it be nicer if we could simply write T1 plus T2 and make it work? Of course we can do that. We will see that in the next slide. So the concept is called as operator overloading. That is a more Pythonic way. So instead of writing a separate add method, I am defining a special method here. We call it as a dunder method. Dunder stands for double underscore. You can see that I have used double underscores before and after the add function. So now whenever we write T1 plus T2, Python automatically calls this dunder method behind the scenes. So it works perfectly well with user defined types also. So that's the real power of operator overloading. Well, here is another interesting one. Let's say we try to print our objects using the print function, just like we do for numbers or strings. Here it doesn't show any error, but the output looks something like main time object at so and so. So this doesn't really help us understand what is inside the object, right? We actually do not come to know what is the value of that object, or we cannot just make out what is the meaning of that. But when we print numbers or strings or lists or any other built-in types, the user gets to see what is the output on the screen when we use the print method, isn't it? Maybe if we want to print an integer which is stored in a variable a, let's say a equals to 2, and when we call print function and pass a as a parameter to it, we get the value as 2. So that gives the meaning, right? So it will show what is the value. But here when we try the same thing with the objects of user defined classes, we get the output that actually doesn't tell us what is there inside the object, or we do not understand what is there inside the object. This is because Python knows how to display those built-in types. It is being trained to do so. There are predefined rules, but it doesn't know how to display our custom objects unless we tell it. We need to teach what to do when it encounters the objects or the custom types. So how to do that? When we saw the list of dunder methods, there was one such method called as string dunder method. We can use that. That will tell Python exactly how to show our objects when we print it. So now if you look at the code on the right hand side, you will see that it prints something much more meaningful. What we got here, 2 hours 30 minutes. So that gives meaning to us, right? So, and this is the real beauty of dunder methods. They make our custom classes act and feel just like built-in ones. Let us quickly see why all this matters. Operator overloading makes our custom classes feel like built-in types. Whatever we can do with built-in types, we can do it with custom classes or our own classes. So instead of calling long method names like t1.add and pass t2, we can just use t1 plus t2. This is how we do it for strings, numbers or lists or various other types, right? So that is more natural, more Pythonic, and this is much easier to understand for others who read it later. So this is one of the big reasons Python feels so elegant, because it hides the complexity behind clean syntax. So, operator overloading is not just about fancy syntax, it is about writing cleaner, smarter, and more human friendly Python. Well, let's wrap this up with key takeaways. Firstly, remember that by default, custom classes don't understand operators like plus or minus or any other operators. We make them work by defining the special methods. That's what we call them as dunder methods, such as add, eq, or string. So doing this makes our code cleaner, more readable, and it just feels natural, like we are working with built-in types. And the best part is, once you understand this idea, you can explore many other dunder methods so that you can make your classes more powerful and expressive. So remember, don't just store data in your classes. Teach them how to behave. So that's what makes Python fun and powerful. So that's all for this session. Thank you so much, everyone. It's been a pleasure, and big thanks to PyLadies for this opportunity. Hope to cross paths again soon. Happy coding. Thank you so much.
Thank you so much, Miss Swarooprani Manoor, for such a practical and insightful session. I believe we've all learned how to make our custom classes behave like built-in types using a magic of dunder method. Such a wonderful, and enjoy the rest of your day, everyone. Bye.